Good afternoon, everyone. Welcome to the third and last working session for today's proceedings. This session will focus on a topic that is gaining increasing significance in the global security landscape, and that is growing power contestation in space. I extend my gratitude to our esteemed speakers for joining us to share their valuable insights on this complex and rapidly evolving issue. I would now request the speakers and moderators to join us on the stage. They're already here. We are honored to have a very distinguished panel with us today for this important discussion. The first speaker for this discussion would be Mr. Dmitry Stefanovich. Mr. Stefanovich is a research fellow at the Center for International Security at the Primikov National Research Institute of World Economy and International Relations of the Russian Academy of Sciences, member of the Council for Foreign and Defense Policy, member of the PIR Center Advisory Board. His research interests include strategic weapons, hypersonic weapons, space, disruptive technologies, arms control, and regional security. Our second guest speaker for today's discussion is Dr. James Acton. He will be joining us online. Dr. Acton holds the Jessica T. Matthews Chair and co-director of the Nuclear Policy Program at the Carnegie Endowment for International Peace. He focuses on nuclear deterrence, arms control, escalation risks of advanced non-nuclear weapons, and nuclear policy. He has published in the New York Times, the Wall Street Journal, the Washington Post, Foreign Affairs, Foreign Policy, and Science and Global Security. Our third speaker for today's discussion is Ms. Juliana Swiss. She will also be joining us online. Ms. Juliana is a research fellow on space security as a part of the military sciences team at RUSI and is the host of the podcast War in Space. Her research interests include global space governance, sustainability, counter-space capabilities, and space warfare. Ms. Juliana holds an MA in Conflict Security and Development from King's College London and a BA in Political and International Relations from the University of Reading. Prior to joining RUSI, she was an intern for the Development, Concept and Doctrine Center, the independent think tank of Ministry of Defense. Then she researched varied topic areas, including geostrategics, security, and stabilization topics, as well as future and contemporary trends in warfare. Our last speaker for this discussion would be Dr. Ali Sarosh. Dr. Ali Sarosh is an experienced researcher and teacher in aerospace systems and technologies at the Department of Mechanical and Aerospace Engineering of Air University. He holds a PhD in space vehicle design and a master's degree in space propulsion technologies. He is the inventor of 2 design patents in hypersonic launch systems and rocket-based combined cycle engines. Dr. Sarosh has been appointed as the member of Technical Advisory Committee on Global Hypersonic Space Technologies by the American Institute of Aeronautics and Astronautics. Dr. Sarosh specializes his research in technology strategies and application for aerospace systems. He has extensively published journal works in space systems design, hypersonic technologies, development of sustainable space policies, strategies for nascent space powers, and counter-space operation. This session will be moderated by Mr. Hamdan Khan. Mr. Hamdan Khan is a research officer at Strategic Vision Institute. He is a graduate of National Defense University, Islamabad, and has worked for Pakistan Council on China and the Institute of Strategic Studies, Islamabad. Mr. Hamdan's area of research are global politics, with a focus on great power politics, programs and policies of nuclear weapon states, and emerging military technologies. I would like now hand over this session to Mr. Hamdan to moderate the remaining of the session. Thank you.
Thank you, Aisha, for the kind introduction. Ladies and gentlemen, welcome to the working session 3 of this Islamabad Non-Proliferation Conference. The theme of this session is slightly away from nuclear and all that stuff, but even in this session, you would hear a lot about nuclear. So without wasting any time, I would be passing the floor to our first speaker, Mr. Dmitry Stefanovich. Dmitry, floor is yours.
Thank you, Hamdan, and many thanks to SVI for hosting me here and giving me an opportunity to share my thoughts on this issue, which is of great importance. I'm also honored by the team that is assembled for this session with lots of old friends and great experts who I'm very happy to know now. So in my remarks, I'd like to cover some basic narratives, basic ideas on how growing power contestation, as you've put it, in space, affects international security and national security. Moreover, I will try to focus on opportunities to reduce the risks and dangers that are there because of the confrontation in space, because unfortunately this is where we are today. Well, current environment internationally hardly contributes to efforts to achieve any progress in securing peaceful nature of space activities. And there are numerous conflicts on Earth, as we've learned during our previous sessions, and these conflicts also spill over to outer space. But actually, space was militarized since the beginning. Military implications of space capabilities were there since day one of the space era. However, now there is rapid progress in different assorted technologies which make the usability of outer space for military operations even more important, and these capabilities provide more and more robust options to enhance the military missions. Third, we have a situation where there is a rapid influx of new actors to space. We have commercial companies, we have so-called new space, and basically these are the ones who are responsible in a good way for kind of revolutionizing the space industry. Now we have a space industry that is much different from what we've seen during previous space eras. At the same time, these were non-state actors, commercial companies, new space companies. They also are becoming increasingly engaged in military activities, and not by some accident, but by design. This is many of those companies do not shy away from arguing that they want military missions, they want military contracts. Fourth, well, there is next to none progress in achieving anything multilateral, anything legally binding that might prevent war in space, that might prevent the weaponization, actual weaponization of outer space. Moreover, even the small progress that is there is being undermined by so-called minilateral formats, by different coalitions of the willings, of like-minded countries, and so on. So there is a very similar dynamic to what we see on Earth in different conflicts. Each of these challenges actually deserves a separate session in this conference or in some other conference, but I will also try to address some broader things. First, well, there are some good news. As unlikely as it is, but an agreed report of a group of United Nations governmental experts on prevention of arms race in outer space has been released, and this is actually quite a breakthrough. It's not something that will solve our issues in space, but it will definitely help us to map a way forward. Of course, the biggest threat, if we speak about space security, is the so-called kinetic confrontation. So when someone tries to take down satellites, ground infrastructure, destroy it for good. But at the same time, even before such confrontation, non-kinetic confrontation, non-destructive confrontation, non-destructive actions against this or that space capabilities and Earth-based capabilities that are relevant to space will take place. And to some extent, we actually see this already in numerous declared or non-declared conflicts that are happening on our planet. Another issue that I would like to draw your attention to is the proliferation of so-called dual-use capabilities. Basically, in space, a lot of things that might be originally designed for benign missions, benign uses, can be then repurposed for malign uses. Vice versa is actually also possible, and we know stories how military capabilities were used for civilian purposes, but we're talking about a process in reverse now. Such capabilities are numerous. One of those are so-called orbital inspectors, a spacecraft that is capable to change orbits, come closer to other spacecraft, and so on, carrying out so-called rendezvous and proximity operations. Originally, it might be a very good capability for any spacefaring nation, for any space activity. You can see what's wrong with your satellite, you might even fix it or refuel it, and so on. But if you can approach your own satellite, you can also approach satellite of your adversary and do something bad to that. Another example is the so-called robotic arms that can be used for sort of experiments, but at the same time that can also do something bad to the spacecraft of an adversary nation or non-state actor. Another very important domain is the so-called space situational awareness or space domain awareness, basically a capability to see what's going on in space. And while originally these capabilities were of purely military nature, now commercial actors are also joining this process, and they also do not shy away of actually engaging in different security issues, basically providing public information about actions of this or that military satellites, and so on. Of course, generally speaking, it is more of a good thing to do, because if we have a more or less clear picture of what is going on in space, what is going on in orbit, and this picture is corroborated or shared by different actors, it might prevent different inadvertent escalation scenarios and so on. But at the same time, space situational awareness capabilities can be used for targeting of satellites, can be used even for missile defense. Finally, I'll say a few words on the implications that this contestation in space and the possible future confrontation in space might have on strategic stability and specifically on sustainability of nuclear deterrence. There is a generally shared view that stabilizing direction of nuclear forces development is to focus on secure second strike capability, on survivable forces, and related efforts to somewhat limit counterforce capabilities that are fit for disarming operations. Because the latter might lead to preemptive strategies being embraced, which is by design very destabilizing. How space comes into play here? Well, space capabilities, especially when they are being pulled by different alliances, like-minded countries, coalitions, and assembled into joint global networks, these capabilities can actually undermine the survivability of second strike forces and enhance counterforce strike capabilities. No matter what's being said about the aims or missions or tasks of this or that developments, everyone will perceive them as directed against their capabilities, especially if we speak about nuclear weapon states. The good news is that now most major nations, most nuclear weapon states, believe that having such sort of capability is good for your own security, and so start to invest in mega constellations and things like that. So effectively it seems that there will be more and more stakeholders interested in preventing kinetic confrontation in space, interested in keeping the space more or less peaceful. But to hedge against possible superiority of your adversary, most countries will also try to develop the capability to, well, destroy such mega constellations. So, in the end, my final point would be that to prevent these negative scenarios, the only way is to have a sort of a legally binding mechanism, a legally binding document that will prevent weaponization of space one and for all, and it should be a priority for whole mankind, because anyway, we should not be always tied to this planet. However, alternative to this legally binding mechanism is the development proliferation of hard tools, of military tools that will prevent weaponization in space. So if someone will put a weapon, there will be a capability to take it down immediately. But first step in a mechanism to prevent weaponization of space is the so-called bilateral joint statements on no first placement of weapons in space. It's great that Pakistan was among the first nations who supported this Russian effort, and to put it in the words that are used by Russian Ministry of Foreign Affairs, it's an ultimate form of interstate transparency, because even if there are some people making jokes that many countries who signed to these statements have no and will never have any space capabilities, it is a very important tool to have a global, or at least a multilateral, understanding of what is good and what is bad in space, which is especially important if we look at the United Nations process, because ultimately United Nations should be the guarantor of the peaceful use of outer space. And with that I'll stop. Thank you.
Thank you, Mr. Stefanovic, for your valuable remarks. Now I would pass the floor to Dr. James Acton. Sir, floor is yours.
I'm sorry. Thank you very much. It's a great pleasure to be here. I'm very sorry I'm not able to join you in person this morning, but it's a pleasure to be able to join you all virtually. I am going to focus here very specifically on the links between the contestation of space and nuclear weapons. And in particular, I'm going to focus on the United States, China, and Russia. And that's solely because I think I understand their space-based command and control capabilities well enough to be able to talk about them. It's not a suggestion that the role of other space actors doesn't matter. It's a reflection of my own ignorance in that regard. And really, there's two issues that I want to focus on this morning. The first are threats to space-based nuclear command and control satellites. And the second is the development of nuclear-armed anti-satellite weapons. My argument this morning is going to be that in both cases, there is a significant and growing risk of deliberate or unintended escalation, including to the point of nuclear use. Let me focus first on this issue of threats to space-based nuclear command and control capabilities. The United States, China, and Russia all use space for the purpose of nuclear command and control, including for early warning, that is, detecting adversary nuclear weapons after they've been launched and they're incoming, and for communicating with their own nuclear forces, including for the purpose of sending potential execution orders. Currently, in the case of the US, Russia, and China, it appears that the most important satellites are in these high-altitude orbits, geosynchronous orbit or more near orbit. The technical details here don't matter so much as the point that the primary threat to satellites in these orbits come from other satellites, so-called co-orbital anti-satellite weapons. If you're thinking about the threats to satellites in low Earth orbit, the main threats currently come from ground-based systems, whether that's direct-descent ASAT weapons or lasers, but for the high-altitude orbits that are used for nuclear command and control, the primary threats are other satellites. And moreover, many nuclear command and control satellites, if not all nuclear command and control satellites, are used for both nuclear and non-nuclear missions. I'm going to use the phrase dual use here because that's the one that I always use, but I use dual use in a different sense from that which Dmitry used it of conventional and nuclear. So I think various risks can arise in this case, due to the development of co-orbital anti-satellite weapons. The first is that in the event that one state was anticipating a nuclear war, or in the event that there had been limited nuclear use, one state might launch non-nuclear attacks on another's nuclear command and control satellites, specifically for the purpose of degrading the effectiveness of the adversary's nuclear command and control system. For reasons that I'm not going to spell out now, but I think are intuitive, that could lead to further escalation. Secondly, in the event of a conventional war, one state might have an incentive to attack an adversary's dual-use satellites, potentially for the purpose of trying to degrade its non-nuclear capabilities. It attacks the adversary's satellites that are involved in non-nuclear missions. But if those satellites are dual-use, if they're also involved in nuclear missions, then the effect of those attacks would be to undermine the adversary's nuclear command and control system, potentially just unintentionally. But again, that could still lead to further escalation. And then a third risk is the possibility that a repositioning operation, that is a non-hostile repositioning operation, the movement of one satellite through space, not in its usual orbit, in order to reposition it to better view or communicate in some way, could be viewed as the prelude to a co-orbital attack. You know, if in a crisis or conflict, say, a US satellite were to be repositioned and were to approach a Russian satellite, that might appear to Russia as the preparation for an attack. And again, that could potentially lead to further escalation. Second issue I want to look at is the development of nuclear-armed anti-satellite weapons. To take a step back, and this is something that Dmitry has already mentioned, the growing threats to satellites of all purposes are motivating the development of these proliferated constellations. That is, constellations with potentially hundreds, thousands, even tens of thousands of satellites in. In the case of the US military, this is separate from Starlink here. In the case of the US military, the US is developing something called the Proliferated Warfighter Space Architecture, which is going to be a dedicated, proliferated constellation for military purposes. Now, according to the United States government, Russia is currently developing nuclear-armed anti-satellite weapons, essentially satellites with nuclear weapons on board. If the US government is correct in that, and I think it probably is, I believe that Russia's program is in part a development to the US proliferated warfighter space architecture. Trying to attack satellites with non-nuclear means when there are hundreds or thousands in a given constellation is simply not going to be practical. A nuclear weapon is, I think, a pretty effective way of trying to undermine an adversary's proliferated constellation. Obviously, there's one very direct pathway to nuclear use here, which is simply a state uses a nuclear-armed anti-satellite weapon to attack another satellites. But I think there's also a risk here of a particularly acute risk here of crisis instability. And this stems from the fact that a nuclear-armed anti-satellite weapon is presumably designed to be deployed in space sometime before it is used, whether that's hours, days, weeks, years, how long, who knows. But this creates particular risk of crisis instability. Imagine that Russia has launched a nuclear-armed anti-satellite weapon. The US has a clear incentive to attack that weapon prior to its detonation. Russia has a clear incentive to detonate that weapon before it's attacked. Each side is fully aware of the other's incentives to go first, and that creates an incentive for each side to go first, potentially to preempt the other side. And I would argue that this risk of crisis instability in space is significantly greater than the problem caused by nuclear threats to nuclear forces. And I'm somebody that worries a lot about the crisis instability implications of nuclear threats to nuclear forces. I don't want to discuss a huge amount of detail about what can be done because of limitations of time. I would just like to say that partly the approach here is technical. I think things like radiation hardening satellites, which if you radiation harden satellites in proliferated constellations, you can significantly mitigate the effects of a nuclear detonation in space. And also partly cooperative. I do think that it would be a good idea to introduce safety zones around satellites in high altitude orbits. This doesn't work in low altitude orbits, to keep potential co-orbital anti-satellite weapons away from nuclear command and control satellites. I think we should look at some prohibitions of activities in space. I think comprehensive agreements to ban the militarization of space it's simply not definable what the terms are. But I do think that we should look at specific prohibitions. Unfortunately, though, all of that is not encouraging due to the state of international politics right now. Anyway, thank you for your time and attention, and I very much look forward to the following discussion.
Thank you, Dr. James Acton, for these very enlightening remarks. Now I would be passing the floor to our third speaker, Ms. Juliana Azus. Juliana, floor is yours.
Thank you very much. Good afternoon, everybody. Thank you so much for this invitation, and apologies that I can't be there in person. Now, I want to start my remarks by talking about the nature of space and talking about how politics and states' ambitions are projected into space. I think quite often there's a misconception that space, is a sort of apart from us, it's an apolitical sphere. That is very much not the case. So if we talk about great power competition on Earth, we will be able to see that in space as well. And the dynamics in space are simply that space has always been militarized. So that means we are using space for military purposes, and we always have, right? This is not something new. Even the first launch of the first satellite in 1957, Sputnik, was also launched for military reasons. So the change that we've seen since then is simply that we've grown much more reliant on space. Increasingly, we are growing more and more reliant on space. So if we're looking at modern militaries today, they rely on space for navigation, communications, intelligence gathering, etc. And the stakes are now higher than they ever were before. For example, if we're looking at the strategic assets that we have in space that warn us of ICBM launches, for example, but also the nuclear early warning satellites that we have. And James has obviously already talked about the nuclear and space entanglement there. Now, counter-space technologies can disrupt or even destroy those capabilities. And again, that is not a new dynamic that we're seeing in space at all. The first counter-space capability was tested back in 1959, so very shortly after the first launch of the satellite. Now, counter-space capabilities encompass temporary and reversible measures, such as jamming and spoofing of signals, for example, all the way to the permanent and non-reversible end, such as kinetic intercepts of satellites, either through a missile launched from Earth or through another satellite in orbit. And that technology is also becoming more advanced. So if we're talking about rendezvous and proximity maneuvers, for example, so allowing satellites to maneuver close to another satellite, these are becoming much more sophisticated. And this is especially important since this means that sensitive military satellites can be photographed, the signals potentially intercepted, and while the intention may not be to inflict any physical damage, these close maneuvers could also be misinterpreted and lead to further escalation. And this is when we talk about the risk of miscalculation in space. And I think this is inherent due to the unique characteristics that we're seeing in space. So conjunction analysis, so the calculation of a risk of collision between two satellites and the position of satellites themselves is always subjective up to an extent. And that is because different actors will use different methods for finding the position of their assets. They'll have different algorithms that they use. So yes, there's a certain subjective nature of being able to tell where your satellites are and where other satellites are moving towards. Now, how do we avoid the potential for miscalculation? I think we need to talk about responsible behaviors in space, because it avoids the decades-long debate and discussion about what a weapon in space looks like. These can be essentially impossible to really define. If we're talking about a piece of debris the size of 1 centimeter, that can have the impact of a hand grenade in orbit. So it shows us that even something that was never intended as a weapon can inflict physical damage akin to a weapon. It also helps us get around the issue of dual use, and the two speakers before me have already sort of touched on this as well. Simple example perhaps are robotic arms, which can help us keep space sustainable by picking up space debris and making sure that satellites that are no longer maneuverable are not in the way, therefore not posing a danger to other satellites, but also they can be used to harm other satellites potentially. So I think a focus on behaviors instead of the technology, which also is continuously evolving, provides a more long-lasting solution and perhaps also leads to us building more trust. Again, I think James has already discussed how the current geopolitical dynamics don't really lend themselves to a long-lasting sort of solution that we can sort of sign immediately. So perhaps we need to take a couple of steps in the meantime. I think we need to acknowledge that we are all incredibly dependent on space, and that's not just the big spacefaring nations. We're all space users to an extent. So I think a bottom-up approach for all to get involved in is necessary for a sustainable approach to space that allows us to operate in the environment in a safe manner. Thank you very much. I look forward to the discussion.
Thank you so much. Thank you so much, Juliana. Now it's turn for our fourth and last speaker for today's session, Dr. Ali Sarosh. Sir, floor is yours.
Thank you, Chair. I have a confession to make. I'm the only mutant in this room, a technologist and a scientist by profession and strategist by practice. So it's going to give you a different taste of how I look at things. It's not purely from the strategy point of view. It's also from how the technology is going to make a trajectory. So I'm going to talk about how the space contest is going to shape the technology in this world. And that technology is going to then transfer into the strategies that will evolve over the next couple of years. For the past 8 decades or more, we have seen that the technology and strategy have been steadily getting intertwined. We are now into the third generation. From a technology perspective, I call it the third generation of space contest. So I'm going to refer it to as Space Contest 3.0. This is an era of changing realities, an era where new powers have appeared and consolidated. There's a formidable challenger to the United States' existing space dominance, and something that US Department of Defense has already accepted in their State of Space Industrial Base 2022 paper, in which they have put China ahead of US as the possible dominant power, a space power, by the year 2045, if not earlier. And that's a very important document. So this Contest 3.0 is actually an escalating competition. It's a competition not just between major space powers, it's between nascent powers, it's also between the private entities. So there are too many stakeholders to this contest now. This is very different from what it used to be in the previous eras. And it's not about prestige, it's not about military superiority, it's about global dominance. That's how it's going to shape out. We want to create a situation where global dominance is established by a group of countries that form allies and team up in this domain. So when we talk about this thing, so my hypothesis on this subject is that there are going to be 4 M's that are going to be very, very important. The first is money. The second is mining. Third is military. And the fourth is morphing. So I'm going to just touch upon all these things and connect them to the technology, how it's going to shape up. It's about creating, money is about creating the space economy. Any space power that does not work on building its space economy will be fizzled out very quickly. The second is mining. It's about actually mastering the ability to extract rare earth metals, rare celestial metals, and also about celestial energy. And so celestial mining is going to be a very important technology of Space Contest 3.0. The third, of course, is military. But this time the military is going to be different. It's going to be counter space operations. The offensive ones will be very specific. It has to be lethal. It has to be cost effective. And it has to reduce the decision OODA loop, which is observe, orientate, decide, and act. The fourth thing is actually the biggest game changer, where people, their mentalities, their lifestyles, their business, the entire society is going to be morphed. So the space technology will be used as a tool for morphing our lifestyles. 4 elements are going to define the growth of space technology. So what are those technological domains that we should be looking at that will help us build these 4 M's? Actually, this thing is already on, so I'm just going to lump together. Instead of going over individual satellites and launch systems, they are lumped together in the net outcomes. The first net outcome of technological domains is accessible technologies and services domain. So we see that there's a change. We are now having near contiguous constellations being built up and very fast. We have recently seen an increase in the launch capacities of all launch vehicles, and the most important is the space segment is now occupied by satellites, which we call as the ubiquitous satellites, so they can have multi-mission satellites. So from dual mode, we are going into multi-mission capabilities. The idea is from the technological perspective, the idea is low cost, very high reliability, ultra low latency, and very high throughput satellites. The dual-use satellite concept has transformed into multifunctional, software-defined, reconfigurable spacecraft that can change their roles and their missions while they are on the orbit. And that used to be not there a couple of years back. This has been tested on the GEO, higher orbit satellites, and now it has been transferred slowly towards the low Earth orbit satellites as well. The second technological domain that we are focused, that will bring about these 4 changes, is that the space powers realize the fact that they cannot remain relevant as long as their products, space products, and their space services are reliable. They can only remain relevant as long as their services are accessible, and most importantly, they are affordable. To make these products very affordable, they have realized that the baseline is to cut down the cost of launch services. So the launch services that used to cost about $25,000 per kilo to LEO about 10 years back have now come down to about $20,000, around $20,000 to $22,000, thanks to the private sector. And it is supposed to get down to about $25 per kg to LEO in the next 30 to 40 years. And that will be the time when your celestial services will be cheaper than your terrestrial services. And that will be when the entire spectrum will be controlled through the space. So that's what we are doing. And that's, if you look at it, since 2015, 10 new such launch vehicles have been added that are either fully reusable or partially usable. We have SpaceX, we have Long March 8, we've got Blue Origin, Chooseway, we got Virgin Orbit, Rocket Labs, all coming up with these specific satellites for this very specialized purpose. The third technological domain is, of course, the military front. We've seen that there is almost continuous and fairly unimpeded development of trans-atmospheric hypersonic weapons. We've seen fractional orbit bombardment system again back in business. We've seen, we can see ASAT systems not going anywhere. We also have sustained directed energy weapons now emerging as a technology. Then we have, as Timothy was mentioning, the RPO satellites, and it's been tested with SJ-21, it's been tested in GEO, and now we would be looking at something happening in the LEO in the coming days. And then we have MTI payloads, we got tactical and celestial data links that are connecting the space to the, right down to the terrestrial surfaces. The military contestation is actually, the outcome of this technology is that the military contestation is focused on shortening the strategic and tactical decision time. And this is done by getting inside the OODA loop of your adversary. So the OODA loop is actually the key. And to get into that OODA loop, we need counter space technologies of the offensive type that reduce this decision time. And that's what the whole development will be focused upon. Now, these 3 technological domains actually result in certain very specific characteristics for this kind of a space contest. The contest 3.0 will witness, of course, this is a race, number 1, for global dominance, as I already mentioned. So it's likely to see some kind of, some form of space colonization coming up in the next couple of years. There will be definitely resource extraction, and that means they're going to witness new forms of dispute over celestial resources. We will also possibly see some form of celestial delineation taking place between the space powers. And there will be a very stringent competition for global influence, because you have to morph people to believe that our services and our technologies are the best. So therefore, there's going to be a very different kind of a competition as compared to what we have seen in the previous 2 eras. On the second characteristic, this is celestial delineation. I've talked about why is celestial delineation going to take place is because there is going to be an energy rush. The world powers understand that the helium-3, the cold fusion energy source, is a vital source. We have already seen that energy relay satellite is already positioned at the second Lagrangian point of Moon, that's by China, and a possible lunar mining is on the card. It's already under development. Then we also see NASA preparing to send its asteroidal mining spacecraft to 511 Davida, and I can say the second one is probably 16 Psyche. So all these asteroids are on the card. The idea is that space contest of 3.0 is actually has a very major component in space mining. And so therefore mastering of new energy and resource supply chains is on the cards. And in doing so, the great powers are tacitly delineating the space territories. This is possibly how it appears to be developing. Then we have the arrival of the private space entities. This, to our side, is actually the game changer. The agents of bringing down the cost of space operations are private sector and not the public sector. So what they have done is they are now producing complete satellite system. We have privately owned global SSA solutions, which is space situational awareness. We have LEO constellations, of course, privately owned. SpaceX is one example. And in August, China launched the Tianfan constellation. This is also privately owned. We have direct-to-home, direct-to-terminal services. We even have space mission operations controls, which are privately owned. We now have launch vehicles, which are privately owned. Things that were not even could not even be thought of about 15 or 20 years back. The idea is that the characteristic of this contest is that the private space entities are not only cutting down the cost of the space products, they are actually easing the access of the availability of space services to the consumer. The World Economic Forum report, 8th April 2024, has also made this thing pretty clear. Space economy is likely to now reach $1.8 trillion mark, and that will be by 2035, in 10 years' time. This is almost 5 years ahead of their previous anticipation, because they believe that the private space companies have played a major role in lowering the cost, increasing the access to services, and bringing about, therefore, a societal level impact on around the globe. So these three characteristics, together with the three technology domains, how are they getting the life? So the lifeline is coming from certain factors. We call them the triggers of attenuation. So they are triggering and attenuating the contest. The first of these is the strategic alliances. There are new power corridors. There is new from the unipolar, we've gone to the multipolar. From multipolar, we might be moving to a bipolar world. In that arena, what is happening is everybody knows, all the space powers know that there is no single know-it-all, do-it-all power that used to be in the 60s and 70s. In fact, there are going to be diversified power centers of space technology and space economy, creating their own ecosystems. And those ecosystems will have to be based on very strong synergy, very strong cooperation, and most importantly, the ability to contest their own adversary groups. So this is actually the first element of triggering. The second element of triggering is the economic factor. We have seen that $570 billion mark, which is 2023, took 20 years to reach this point. And it will take just 10 more years to jump this $570 billion mark to over 1.8 trillion. That's almost 4 times and half the period. So with this thing on, the private sector is all for grabs. So they are the ones who are actually now fueling the Space Contest 3.0, keeping it alive. The third thing is the trade wars between the countries. Of course, we've seen US and China trade war, and it has all the potential to engulf the space sector as well. We strongly believe that. The nanochip war that's been going on in Taiwan, has already exhibited that it can pitch superpowers in open seas. It can seize production of aerospace and automobile industry. So imagine when the space industry matures into a full-scale economy, private sector becomes stronger than the public sector space entities. The economic interests of private space entities can very well, and we strongly believe, can get space powers to pitch against each other in outer space. We say that trade wars can switch to Star Wars in just the spur of a moment. That's how it's shaping up. And the last thing is, which should be always natural, it's an organic factor, is the Thucydides trap. I'm a very strong believer of the Thucydides trap because we have the perfect recipe of Thucydides trap now in place. We've got a receding power, and we got a rising power, and we got a resurgent power all in the game. So the dynamics of Thucydides trap cannot be removed from this whole picture. President Xi Jinping, in a 2014 address, has already mentioned this thing, and I quote, "We all need to work together to avoid getting into the Thucydides trap," unquote. If we build a converse of this kind of a Thucydides trap, the great powers might become where great powers might at some point become belligerent in outer space. The capability to contest the adversary will not be on historic grounds. It will be actually on technological grounds. And there are 6 factors that we enlist in this case. The first factor I already mentioned is the speed with which the OODA loops will be running through the counter space operations. The second will be the ubiquity that the space systems will be offering to the to their own, to the allies. The third is the terrestrial permeation of the celestial services that will affect the people on ground, so making them loyal to a particular group of the space powers. The fourth will be the extent to which counter space technologies will be able to protect own assets and attack the aggressor if that situation arises. The fourth will be the robustness of economy, for how long the whole thing can be sustained. And the sixth item will be the cooperation between the allies, the degree of synergy that exists between the groups that form a particular space power. So based on this, there are certain, because we are sitting, of course, from that point, we can also have a look at how Pakistan stands in all this. Just a small, excuse me, just a small 2 cents for Pakistan on this aspect. Pakistan is almost like any nascent space power on the rise. And of course, it's been a little erratic, the passage. Our best chances are at converting threats into opportunities. We know that we have a very limited space program at the moment. This is a threat itself, but it also offers two opportunities. The first opportunity is that there is practically very little in the space economy that we have done, so that there is a huge margin. And if we can tap on the potential of space cooperation, then we can actually build our space economy from ground upwards. Secondly, a smaller space program also means a smaller threat matrix. And I've given a talk on this at a previous event. So that means lesser commitment for military space tech as of this moment. This will leverage more economic freedom to build a civil commercial space program. So how to get into that space program? Pakistan might need to correct its strategic alignment in the realm of the growing space power contestation. There are three things we should do. First, we should reassess our national space policy. There are certain shortcomings there. We need to first effectively align the space policy with UN's Space 2030 agenda. We've already made a commitment there, but there is no mechanism mentioned inside. Secondly, we should propose a workable mechanism for civil corporate setup to be working within the space sector. We have already shown the commitment for this also, but there is again a missing link inside as far as the mechanism is concerned. Then we need to reduce reliance on purely on the national space agencies for sustaining and developing commercial space program. In fact, we need to promote and support corporate sector to be doing this job for us, and they can get in touch with the global space companies because there are no regimes in the civil sector. So you can connect with these companies very easily. Our objective as such should be to become a credible continental space power in the next 4 decades by developing a consumer-oriented space economy, one that is based on public and private or private-public ownership for providing 4 core services: celestial broadcasting, celestial internet, education, GIS, and very importantly, ultra-low latency telecommunication, because our telco sector is probably the best we have at this moment. It's only through these people-oriented projects that Pakistan can accrue true benefits and resist the temptation to become another proxy in the space power contestation within the great power competition. Thank you.
Thank you, Dr. Ali Saroj, for such an elaborate discussion. It was actually quite different, but very enlightening. Thank you so much for that. So, ladies and gentlemen, before opening the session for Q&A, I will have just another round from our speakers. If they want to add or respond to something, then we will move to a Q&A session. Dimitri, would you like to add something? 3 minutes.
Okay. It was really interesting to hear perspectives from my co-panelists. And I would emphasize that it is a very good idea of SVI to gather people with different backgrounds, with different priorities in their research for this panel. So it's actually, to react in 3 minutes would be too hard of a task. I need, as I've said earlier, each of the topics that we've mentioned, like we have 4 or 5 of us mentioned, deserves separate sessions. So my major point would be that, once again, as we are here at a non-proliferation conference, it is a bit countering to the opposite to what is going on in space, because in space we have proliferation of capabilities, proliferation of satellite constellations, and so on. And with that, we might also see proliferation of anti-satellite capabilities. However, to manage it Well, I think the first step would be is to actually map the threat perceptions, map the way people think about space contestation in different countries. Because all those capabilities that were mentioned should be the commercial, but more importantly, the military capabilities that we are discussing. They do not come up, countries do not come up with those, countries do not develop those simply because like they want to have fun, they want to test this or that concept. It is always a result of a very specific threat perception by this and that country. So, as James clearly stated that proliferated satellite constellations, mega constellations, were a result of development of anti-satellite capabilities, and then tools for mass destruction of satellites is a next step, but we should take a few steps back. Like anti-satellite capabilities, they also began to be developed and fielded to some extent because of superiority, because of dominance in like regular satellite capabilities and the missions they could have fulfilled in the military domain. So we'll see what will be the next steps, and thank you once again.
Thank you. Thank you so very much. Dr. Acton, if you want to add or respond to something, you have 3 more minutes, 3 to 5 more minutes. Thank you.
Thanks. I've spoken long enough, but I'd actually like to ask Dimitri a question, if that's okay. Dimitri, you mentioned the Russian initiative for bilateral agreements on the no first placement of weapons in space. And you also mentioned, I think entirely correctly, that Inspector satellites have both entirely peaceful purposes and offensive purposes. They're able to service or repair your own satellites potentially, but also disable an adversary's satellite. A particularly good example of this is the US Space Shuttle. Obviously, that's a defunct system now, but the Space Shuttle was funded in part by the US military for the purpose that it wanted the ability to pluck Soviet satellites out of the skies. It wasn't used for that purpose, but it was used for the purpose of plucking an American satellite out the sky in the case of the Hubble repair mission. I guess imagine that there was a US-Russian bilateral no first placement of weapons in space, and the US revived the Space Shuttle program. And obviously, this is a very hypothetical scenario here. But in your opinion, is the US Space Shuttle a space weapon?
You'd respond to that straight away.
Okay, thanks. Sorry for ruining the process, but I'd say kind of an anecdote, but with very serious implications. Back in Soviet Union, and now we have plenty of documents and memoirs on that, the space shuttle was perceived not only as a tool to steal satellites or even space stations, but also as a tool for orbital nuclear bombardment. So it was considered a very real weapon back in the day. If we look at the situation today, I would also mention like things like X-37B is also perceived as possible thing that can be used for military purposes. I think the important word that is used by Russian officials when explaining these statements, no first placement of weapons in space, is the transparency. It provides way for interstate transparency. So should Russia and the US engage in discussions on such a joint statement, I'm pretty sure the first step would be to ask very tough questions to each other about the sort of capabilities, and then we might come up with solutions, including solutions in terms of so-called behavioral arms control, which was partly mentioned by Juliana. To come up with assuring each other that this or that capability is of limited utility as a weapon, to put it this way, because effectively a lot of things in space can be used as repurposed as a weapon, should one need to do so. Again, it's not a perfect solution, I remember a lot of American Space Force, Space Command officials arguing that some of the Russian inspectors, Russian space orbital inspectors, are actually space torpedoes. But yeah, it would be a good topic to start bilateral and probably multilateral discussions, because of course it's hard to have these discussions with some of the countries who already signed up to this no first placement in space. But again, if we look at the broader issues like the PPWT treaty project by Russia and China, current attitude is very negative from the US and some of the US allies, but it could have been turned in a more constructive manner if we start with the discussion what actually we are discussing that should not be placed in space. Because again, there was some trend to bridge the gap in perception of space security and tools to achieve it when at, I think it was UNIDIR Outer Space Security Conference a few years ago, maybe in 2021, where actually to a direct question, I think from a British diplomat about whether anti-satellite, ground-based anti-satellite capabilities, so-called direct ascent ASAT, will be covered by PPWT, the Chinese diplomat responded, yes, of course, because there will be no targets in space for ground-based anti-satellite capabilities. So there is possibility to bridge the gap while engaging in discussions about this or that initiatives, not simply brushing them away.
Thank you. Thank you for the response. So, Ms. Juliana, 3 minutes more for you, if you want to respond or add to something.
Thank you very much. Yes, I just want to pick up on a couple of trends and dynamics in space that we've discussed since then. I think number one, and it's come up just now again as well, is transparency. I think, you know, what used to happen in space back in the 60s and 70s, you know, specifically what we saw, what was then the Soviet Union and the US, was all sort of hush-hush happening behind closed doors, but that is no longer the case. Even you know, hobby astronomers at this point can tell where certain assets in orbit are. So I think when we talk about attribution in space, and I think quite often the lack of attribution is cited as one of the difficulties when it comes to space and counter space activities in particular, I think that is becoming less and less of a concern. I think the amount of transparency that we now have in space allows us to have a pretty good picture of what is happening, and that also counts, of course, for commercial actors as well. Which brings me to the next point, and that is the diversity of actors. The new space sort of phenomenon, if we may call it that, has obviously already been mentioned. I think it's been interesting to see, obviously, how, you know, the decreasing cost of launch has enabled more and more also commercial actors to get involved in the domain. But I do think we need to be aware of sort of the constrictions here, because I do think specifically what we've been observing in the war in Ukraine, you know, everyone suddenly talks about how it's completely new that commercial actors are getting involved from the space domain, and that's simply not true. I mean, if we're looking at the American campaigns in Iraq and Afghanistan, 90% of the bandwidth at the time was provided by commercial providers as well. So I think we do need to be wary of the sort of press headlines that we sometimes see. And I think lastly, I think we've touched on it a little bit, and specifically James has mentioned it as well, that's the resilience element and the proliferated constellations in particular, and the extent to which we now have to be aware of how resilient space assets need to be, not only to sort of harden them against specific counter-space threats, but, you know, also taking into account environmental factors, space debris, solar flares, etc. So, you know, the need for commercial, I think, is almost built in at this point to be able to guarantee service. Thank you.
Thank you. Thank you so very much for your comments. Dr. Ali Sarosh, you have 3 minutes if you want to add or respond to something.
One point on this, again, coming back to the commercial space actors, we consider them as the game changers for the ongoing space contest. Unfortunately, within the non-proliferation regime, this is an issue because they are very limited legal frameworks, right, now covering the work of private sector. And this actually makes things very opaque. So possibly in the coming days or years, all the major space powers will have to get together with the nation powers, together with the private sector, to actually establish a well-defined legal framework of how they are going to function We've seen SpaceX being, I guess, fined about $0.6 million recently for using a propellant that was not cleared by FAA. And these things are going to actually grow. And we, just as Dimitri was also mentioning about the possible proliferation of military space tech. And this anything could happen. So unless we do not have sufficient controls established in this domain, we might find ourselves in a quagmire-like situation in coming years, because they're going to be private sector, they're not public sector. So it's going to be difficult to handle them. So we need to put a well-defined legal framework, a mechanism, we call it the regulatory framework, and we let them grow, but grow with the certain regulations. Thank you.
Thank you so very much, ladies and gentlemen. Now the session is open for Q&A. We would appreciate questions. Kindly introduce yourself. And then as far as your question is concerned, please be very precise. Dr. Adil to start. I will come to later.
Thank you very much. I'm Adil Sultan. I teach strategic studies, which include politics of space at Air University. First question to James. Good to see you, James. You talked about Russian satellite, that space-based nuclear-based anti-satellite weapon. Russians might term this as nuclear-powered satellite. So, in your view, how Russia might use this nuclear-based satellite as an anti-satellite weapons, because it is not going to destroy only US-based satellites. Nuclear explosion in space is going to affect the entire space and affect all other countries. Juliana, I'm very fond of your podcast from Rusi. I heard somewhere you drew comparison between geopolitics and astropolitics. Like on geopolitics, we work on geography, and in space there are orbits. So, what are the? How do you compare these two? How this competition you can compare with geopolitics and astropolitics? Dr. Sarosh, for you, thank you very much for this presentation, which was enlightening in a way some of the technical issues that you explained to us. And the role of private industry. Elon Musk now controls more than 2/3 of satellites. So that's the influence they have. And the low Earth orbits, they have a limit. If private industries and other countries, they start to, as they're sending thousands of satellites, eventually there would be saturation. How countries like Pakistan are going to be affected in that term, one. Secondly, you talked about celestial mining. Now, this is very interesting because everybody who has the potential, they are rushing to moon and to, as you said, also for resources. Once there are commercial interests, then definitely major powers, they will have the military presence over these celestial bodies. Already, Toyota Buggy is working on something that humans can stay for a couple of weeks over there, and some countries are attempting to build bases in the future. Do you think that kind of militarization on celestial body is going to be there once the mining or the commercial interests grow of these major powers? Thank you very much.
Thank you, sir, for your questions. I think we'll have a round of questions. Next question is from Mr. Zahir Kazmi. Sir.
A question to all the speakers, two common points. The first one is that what would potentially prevent the space powers from launching a verifiable initiative or a treaty that bans all anti-satellite weapons rather than just calling for a direct assent weapons ban only? That's my first question. And drawing from what James earlier said, asking Dimitri to define a space weapon, since all the speakers, I assume, agree that we should aspire for prevention of arms race in outer space and potentially reach a treaty on that. What could be a baseline definition, in your perspective, what constitutes a space weapon on which at least 4 of you can agree to? Thanks.
Thank you. We can have one question from Dr. Nasser.
Thank you. I'm just wondering, if we can find an opposite of militarization of space, can it be civilization or civilized behavior in space? And what are the regulatory mechanisms to have a civilized and more responsible behavior from the powerful nations which are having a nuclear program? In fact, I'm asking this question to all the panelists in the backdrop of the recent explosive attacks through pagers and through walkie-talkies by the Israelis to target Hezbollah. Why it is relevant? Because it has shattered the confidence of the consumers on the technology-based whatever instruments are there, whether they are terrestrial or they are non-terrestrial or in the space. So what is the regulatory mechanism to restore the confidence of consumers, whether they are national or they are whether they are private or public sector, that these are not going to be used to target or to spy onto them? Thank you.
Thank you, sir. Dimitri, you would like to respond?
Oh, okay. I'll start. I would also try to answer the question about how to use a nuclear-tipped anti-satellite capability. Well, clearly there is, I think, no conflicting interpretations here that it is a genuine weapon of orbital mass destruction, and no one will get away from it, at least at selected orbits. So my perception is that first, it is a weapon that will not be deployed there at peacetime, contrary to what some people argue, because it makes little sense. It's not that hard to deploy it when there is a conflict, and then use it. Second, it will be a situation where something really dramatic is already happening on Earth's surface. But alternatively, there are some interpretations that it might be as also sort of a deterrent capability when it is not deployed in space, but when it is on Earth, so somehow it will be a thing that can prevent further escalation, because there will be a belief that we can make it to a step higher. I doubt that it works, that such thinking might help, but so far I haven't seen any very detailed explanation on the scenarios of use. And finally, on this topic, I would mention that even some of the US military officials, they say not about like a project to develop a weapon, but something like a project to look into a possibility of thinking if it will make any sense to deploy such weapon. So I think we're still quite far from this development. But as a natural reaction to proliferated mega constellations, it does make sense hypothetically, but in practical terms, I doubt that there was deep understanding. Second, on a definition of weapons in space, of space weapons, I think we can actually start from something to find at least some group of such capabilities, and it might have something to do with tools or spacecraft intentionally developed for kinetic attacks against spacecraft or of other countries or Earth-based capabilities. But it will be like really, really baseline, because there will be a lot of other capabilities of military or even weapon nature that will not be covered by this definition. But we can start from that. I doubt that it will be easy to agree or even on this small definition. But, well, we need to start somewhere, because alternative is way harder. And on civilization, in how to make space civilized, I mean, there is so many, such a level of degradation of civilization in other domains that to think that we can make things better in space without making things better on Earth, well, I have doubts about it. Although, of course, it might be a very good initiative to embrace, just to show that, okay, we have problems on Earth, but in space we will agree not to beat each other to death. I don't think that under current environment it is possible, but civilization as an opposite to militarization is a really good term. Thank you.
Thank you, Dimitri, for your detailed response. Dr. Acton, would you like to respond to the questions raised?
Sure. Let me respond to the Air Marshal's question first. Any use of nuclear weapons in space would have vast and indiscriminate consequences. I point out the same could be true, of course, with the use of nuclear weapons on Earth. I mean, it depends a bit more on the scale, the size of the detonation, its location. But it's not as if you could use nuclear weapons on a large scale in Earth without having massive indiscriminate consequences that affected countries besides the belligerents. So, I think the argument would be for why this kind of space-based nuclear capability would be useful is because if you're faced with losing a large-scale conventional war to the United States, which is potentially an existential threat from a US adversary's perspective, maybe the use of nuclear weapons in space looks less bad to you than the use of nuclear weapons on Earth. At the end of the day, the use of nuclear weapons in space would be massively indiscriminate. It would destroy satellites, numerous satellites belonging to third parties. It wouldn't kill people on Earth directly. It might kill them indirectly, but I think you could make a pretty persuasive case to yourself that it would be less bad to use nuclear weapons in space than in Earth. Then, in answer to the question, let me deal briefly with the questions about definitions and dealing with all ASATs. I don't know how to define a space weapon. I think the issue here is it's the behavior that matters, not the weapon. If I have a satellite that I have designed to, some kind of space servicing satellite that I've designed to come to approach my own satellites, repair, service, resupply, whatever. Exactly the same capability could be used to destroy an adversary's satellites. And so for me, the issue here is behavior, not in general, not capability. Now, I think there may be exceptions to that. Obviously the Outer Space Treaty prohibits the placement of weapons of mass destruction in outer space. Maybe one can think about a better defined and verified prohibition on space-based nuclear weapons. It's going to be tough. Maybe that's possible. And, I would recognize that clearly that kind of agreement is much more in the US advantage than it's in Russia's advantage. In terms of the question about dealing with all ASATs, I have slightly conflicting impulses here. If your satellite is being jammed or dazzled, if your satellite, especially if it's being irreversibly attacked with non-kinetic means, that's a big deal for you. On the other hand, direct-to-center attacks are particularly bad because they produce loads of debris. And that's a problem for everybody in space. Part of the reason I thought the US initiative for a moratorium on on the testing of direct-to-send ASAT weapons was a good idea was because it was a limited prohibition. It was clearly definable, clearly verifiable, pretty useful as well. So, generally where I come out on these issues is it's very good to discuss these issues like definitions. I think the US government makes a big mistake by not even being willing to engage on Russian and Chinese treaty concepts. Even if you think it's not possible to reach an agreement, I think there's a lot of benefit by having the discussion. B, behavior's really what matters in space. And C, though there may be some very specific things like nuclear weapons in space, direct-to-send testing of direct-to-send anti-satellite weapons, where you can make progress on legally binding prohibitions. Let me leave it there.
Thank you. Ms. Juliana, your response to the question, and if you'd like to add something.
Yes, thank you very much for those questions. Interesting question about geopolitics and astropolitics. Obviously, astropolitik, a sort of term that first came up sort of at the end of the last century with Everett Dolman, which obviously tried to picture space as a specific environment as well. But I do think we can also see of where geopolitics and astropolitics sort of, merge and become one thing. If we're looking at the geography of a state that also decides, for example, its launch advantages or, disadvantages, for example, where certain states actually have to, if they want to launch into space, would have to launch against the Earth's spin in order not to overfly other countries, and therefore, obviously, the potential being debris sort of falling down over other countries, posing particular risks, etc. So I do think geopolitics and astropolitics can become sort of blurred. I think in general, when we talk about politics, great power competition, space is part of that already. We cannot see it as a sort of separate entity to that. It's not, there's probably a joke to be made here about space not being a vacuum. So I'll leave it on that bad pun. Talking about arms control treaties in space, I just want to bring it back to the difficulty of verification. Something doesn't have to be a weapon to be used as a weapon. So even if we have all these treaties that say do not place weapons in space, someone could use a satellite used for, I don't know, medical experiments, something, inherently civil, and could just use that satellite and maneuver it into another satellite, thereby using it as a weapon, right? So at that point, that treaty wasn't necessarily broken, but something was still used as a weapon in space. So it's really, really difficult to sort of set those, set that type of arms control, because it has to be behavioral. It can't be based on the technology, because as I just outlined, the technology doesn't have to be made to be a weapon, to be used as a weapon. And I think a similar thing goes for the civilization of space, the question that we had. Things are inherently dual use in space. Most things are dual use. That doesn't mean they're dual purpose, meaning they're not designed to be used for military and civil purposes necessarily, but they could be, right? If you have an Earth observation satellite, for example, that gives you amazing analysis and data on, for example, how different crops are growing in terms of climate change indicators, etc. But it can also be used to tell where military infrastructures are being built, and gives you intelligence in that way. So someone's Earth observation data can also be used as someone else's intelligence, depending on the areas that were flown over. So dual use, we can call it a dilemma, sure, but there's also advantages in that too, right? So I think dual use is just something we have to accept when we're talking about space. And just one other quick comment about arms control treaties, when you were saying sort of, where can we already meet? I think it's also important to remind everyone, because we haven't mentioned it yet, that the placement of weapons of mass destruction in space is already forbidden under the Outer Space Treaty of 1967 and was signed by numerous states. So that is already something that is technically forbidden. Thank you.
Thank you. Thank you so very much. Dr. Elisa Roche, your response to the questions.
I'll start with Dr. Adil's question. I will make a small comment. While on the geopolitics and astropolitics side, the gray area is very big. So the variables are large, but from a technology status point, the situation is much simpler. So first thing, there is a very very clear definition for what a space weapon is. Anything that attacks a celestial asset is a space weapon. So if you have an airborne platform that is going to destroy somebody's satellite, is going to attack from space to space, or from space to Earth, staying beyond the carbon line, that is space weapon. And the definition finishes there. It's very simple and very crisp. And everything falls in between. If there's a simple satellite that has no arms on it, no weapons on it, no robotic arms on it, but it has been called in to do a rendezvous proximity maneuver with the intention of deorbiting another satellite or damaging a satellite, so it's a space weapon now. So the definition as far as the space weapon is concerned is very clear. But if you do the same RPO for the purpose of doing servicing of the satellite, recovering the satellite, uploading a certain data, that's not a space weapon. But if you come in and do an RPO with the intention of just monitoring what the data is being processed on the satellite, then it becomes another space weapon. So it's the intention that matters. And it's how you're going to use the space asset in the orbit. So from technology standpoints, it is pretty simple. Sir, the question of saturation of the LEO, as yet, we are pretty far off from the saturation point, because the space is pretty big. But the way the near contiguous satellite constellations are growing, the problem is not saturation that's going to come up. The problem is something called as the Kessler syndrome. The Kessler syndrome is it's measured by a Goddard graph. The rate at which the chances of the collisions will start to increase. At the moment, the collision chances are less than 0.1% in the lifetime of a spacecraft. The moment we have all these constellations, let's say we have another 10,000 satellites in orbit. SpaceX is there, Tianfan, all have their 25,000 small sats in orbit. At that time, the possibility will jump to about 1%. That's a very big jump. So it may not be exactly that we're going to saturate the orbit. We are actually going to risk the orbit. And so the space safety concerns are going to be there. So therefore it is linked to sustainability of space operations. So we have to look at it from that perspective. Therefore, minimum separation of the orbits has to be maintained. And so at the moment, UNOSA and ITU, all these agencies under the United Nations, they cover these requirements of minimum separation between the orbits. That's also done when you launch your own satellite. So the minimum separation must be there so that you are safely out of phase, I would say, and the risk of collision is very, very low. And out of phase with the other satellites also in the neighboring orbits. So I hope that answers. On the celestial mining, the way things are happening, as yet the extraction has not started. That habitat built up is obviously, we all know, there's a lot of research going on, how to build the lunar habitat, how to do the asteroidal mining. If at some point we are able to break through, get the cold fusion energy transported, let's say theoretically, even to Earth, at that time the risk is going to be high. And that's why I exactly mentioned in my talk also this fact, that the nature of conflict will change. Because at that time, even celestial assets will be the celestial delineation, even hypothetical delineation will be there. I mean, NASA retrieving from lunar mission and going for asteroid and leaving the lunar assets to China actually means that China's Chang'e 6 is now there, the only rover that covers the dark side of the moon. There is only one Lagrangian satellite that covers a relay of energy from the dark side. So it naturally becomes, for a very long time, their piece of land. Similarly, 511 Davida, where
Professor, sorry to interrupt you, but if you can conclude, because we want to take another question. Thank you.
So as far as the ASAT weapons are concerned, I've already covered the definition of the basic space weapons. Dr. Nasser was asking about the militarization versus civil space. Technologically, there are 6 jobs that a satellite does: remote sensing, communication, navigation, scientific, military, RCNSM. Unless you categorize a satellite as a military satellite, otherwise, if it is a single-use satellite, a single-purpose satellite, it's going to be a civil satellite. So the opposite is precisely civil space. So we have military space and we have civil space. And the definitions are very valid. And you cannot destroy a civil space satellite because that will take you on a legal discourse for a very long time. Thank you.
Okay, Stuart, thank you so very much for this detailed response. So we still have a few more minutes, so perhaps we can take another question. Sir, kindly introduce yourself and then kindly tell to whom you have addressed this question. Thank you.
Dr. Shamsi here. Any of the distinguished speaker can answer this question. My question is, how do you convince the powerful states to refrain from race to space? We have the models available. NPT was in place, but we could not convince the states from getting nuclear. Other treaties also, we have the model of arms control and disarmament. And I don't think we can glorify those arms control or disarmament treaties because we are presently in World War 2.5 at the moment. And here in 2024, we are talking of space dominance by 2045. We are in 3.0 at this stage as far as the space is concerned. I think for traditional and non-traditional weapons also, we started discussing disarmament from generation 2 to now reached generation 5. So therefore, we have all the models available. We were unable to convince the technological superior.
I'm sorry to interrupt you, but if you can be precise so that we can have yet another person.
I'm very precise. I just want to know.
Thank you.
I just want to know if the speakers can point out how to convince the developed states from not going into race into space. Thank you.
Thank you. Thank you so very much. So we have a lady. Can you hand over her the mic? So we'll.
Assalamu alaikum. Zubaida Basi here, Prime Minister Secretariat. Sorry, I cannot afford the liberty to not associate myself with my parent organization. Apollo-Soyuz test project was first crewed space mission jointly carried out by Soviet Union and America. But in 1975, during peak Cold War era, given this context, would Dr. James, US, and Steph, Russia, would pursue or advocate for any of such initiative if taken by any of such aforesaid states, given the element of China as well, since International Space Station is retiring soon and ILRS is already taking place? One thing. Second thing.
Can we just settle with one question because we are already short of time? So thank you so very much.
Thank you so very much.
The speakers, Dimitri, would you like to say to what to respond to two questions?
Okay, I'll try to be fast. First, well, the good news is that we still cooperate with the Americans on the International Space Station. And I think that even as we are planning to develop our own space station, and the Chinese already have their own space station, some sort of cooperation will continue with inclusion with the US and possibly other countries who will develop tools for develop spacecraft for crewed flights. Because like it is definitely one of the parts where we can engage in military-to-military, scientific-to-scientific cooperation, and it will have good repercussions in other domains. And to the question how to convince developing states not to race in space, well, I don't think we should. I think developing nations, developing countries should engage in space activities. The challenge is the opposite, how to convince spacefaring nations to give access and share technologies with the developing nations. It is very different compared to what we see in other domains. And unfortunately, some of the mechanisms that are in place, for example, missile technology control regime, sometimes affect the ability of developing nations to actually develop space assets. Thank you.
Thank you so very much. James, quick comment in response to these questions. Thank you.
Yeah, let me just respond to the question about US-Russia cooperation. Civilian cooperation in space is way outside my area of expertise. I think it's a very good idea. The kind of cooperation that I would advocate and like to see is cooperation on norms of behavior. One of my own personal ideas I promoted is these safety zones pertaining to high altitude orbits, geosynchronous and Molniya orbits. But basically, there's a lot of technical detail here I won't get into, but is the idea that in those orbits, states agree not to maneuver their satellites within a given distance of other state satellites, unless they give pre-notification ahead of a non-hostile repositioning operation. So, in looking for cooperation, I wouldn't just look on the civilian side. I think there is the potential for military cooperation in military areas would be a good idea. It is politically very, very difficult right now.
Thank you. Thank you so very much. Juliana, your quick comment because we are just at the conclusion of our session.
Yes, I mean, first of all, I would like to agree with everything that James has just said. I just want to add something because you used the Cold War example. And I think quite often we look at the sort of space collaboration that happened at the time and think how it sort of furthered and sort of, eased diplomatic tensions. That's actually not true. So there was some research done by Dr. Aaron Bateman, who actually found out that any sort of space collaboration that we saw, including the 1975 mission that you just mentioned, always happened after diplomatic breakthroughs had happened in other areas. So it was more sort of effect rather than the cause of actually easing tension. So I think we need to be careful with that and sort of cause and effect here. Thank you.
Thank you so very much. Dr. Ali Sarosh, your quick comment.
Yeah, on the cooperation side, this May 2024, we've had a very important development. Russia was planning to pull out of the ISS program, and it took the US side a lot of time, a long time to actually convince. And this is despite what was happening in Ukraine, because civil cooperation is so important that Russia decided to actually defer this pulling out for another 10 years. And immediately after that, we now have a seat swapping agreement between Roscosmos and NASA and the ISS consortium, in which they can stake their astronauts, the Russian astronauts, aboard the American spacecraft, and vice versa. And so this is a very important development, as important as you mentioned, Apollo-Soyuz docking of 1975.
Thank you. Thank you so very much. So, ladies and gentlemen, let's give a big round of applause to all our speakers for this very enlightening and fruitful discussion. Mr. Dmitry Stefanovich, Dr. James Acton, Ms. Juliana Zeus, Dr. Ali Sarosh, thank you for participating in first Islamabad Non-Proliferation Conference. We are really honored and privileged to have you speak here. Thank you so very much. This brings us to the end of our session. Thank you so very much, ladies and gentlemen.
Thank you to all the speakers for their insightful discussions and to the audience for active participation. Now I would like to invite Dr. Naeem Salek, Executive Director, SVI, to present the conference mementos to the speakers and moderator. I would first request Mr. Dmitry Stefanovich to receive the conference memento. I would now request Dr. Ali Sarosh to receive conference memento. Now I would request Mr. Hamdan to receive his conference memento.